Plate tectonics is a theory that explains how the movement of Earth's plates influence many of the phenomena occurring here on Earth, such as volcanoes and earthquakes. Before we can fully understand plate tectonics, we first need to understand the underlying structure of the Earth. Earth is divided up into multiple spherical layers, starting with a solid inner core, a liquid outer core, a more viscous mantle, and then the solid outer crust. The movement of tectonic plates can be traced all the way back to heat in the Earth's core that rises through the mantle to form convection currents. These convection currents pull on the plates in the lithosphere to move them. When plates are pushed together due to converging convection currents, this is considered a convergent plate boundary. When an oceanic plate converges with a continental plate, the oceanic plate is denser and will then subduct beneath the continental plate. A trench will form where the oceanic plate subducts, while stratovolcanoes will commonly form over the subducted slab. Common examples of these oceanic-continental convergent plate boundaries can be seen along the Ring of Fire, located in the Pacific Ocean. This is very similar to when an oceanic plate subducts beneath another oceanic plate. The older and denser plate will subduct beneath the other, forming a trench. Volcanoes will initially form below sea level and then can possibly grow to reach above sea level. This can form an arc of volcanoes and is sometimes referred to as an island arc, an example being the islands of Japan. Earthquakes are also likely to occur at these convergent margins because the plates are slipping past each other. A third type of convergent plate boundary is a continental-continental collision. When this type of collision occurs, neither continental plate is dense enough to subduct beneath the other, so a huge mountain range is usually formed as a result. An example of this can be seen when the Indian plate and the Eurasian plate collided and formed the Himalayan mountain range as a result. When plates are pulled apart due to diverging convection currents, this is referred to as a divergent plate boundary. When two oceanic plates diverge, magma will rush up to fill the newly formed gap, which creates underwater volcanoes, which will eventually form new oceanic crust. This can result in an underwater ridge, an example being the Mid-Atlantic Ridge. When two continental plates diverge, a valley will initially form on land. Usually this gap will eventually be filled with seawater, instead of magma rising to form volcanoes. When a continental plate diverges from an oceanic plate, mixed results can occur and usually depend on the location of the fault line. Transform boundaries are a third type of plate boundary where plates slip past each other laterally. Because these plates are not moving towards or away from each other, geological features such as volcanoes are not formed. Over time, a lot of pressure can build up when the plates are trying to slip past each other, and as a result, lots of earthquakes generally occur around transform boundaries. An example of a transform boundary can be seen along the San Andreas Fault in California.